Now, in problem number 27, there's an apology embedded in here. And that is, I never described what is meant by linearization.
Yeah, that's why I was confused.
But there happens to be the word linearization actually in the book, in the same section which we're doing these problems. So, just in case that you wanted to find out what that meant.
But I did not.
I bet that was slide number 14, wasn't it?
It was a slide we didn't get to.
No, it just means
That's what I just said.
linearization is just a fancy way of saying that we're doing a Taylor polynomial of order 1. Meaning the highest value of x, or the highest power in x is going to be the first. It's going to look like a linear equation. The first, which is a constant, plus some multiple of x, which makes it look like a linear function. So, let's find the linearization of the natural log of cosine. So let's start with our table, n, f of n at x, f of n at a, and then c of n, which is equal to f of n at a divided by n factorial. Has everyone got that? So like, you just like spew it off now? Then you haven't done enough problems.
I'm saying yes.
Okay, so the function, the zeroth derivative is the function itself. And in this case, if a is equal to 0, cosine of 0 is 1. The natural log of 1 is 0. So we get 0 divided by 0 factorial, which is 0. Let's go look at the first derivative.
So if you put emphasis on 0 over 0, it is
Negative tangent.
Okay? So the derivative of this is 1 over cosine, but there's a chain rule which gives us a sign.
Negative.
So we end,
Negative.
oh, it's negative. So indeed, the derivative is negative tangent.
I got worried for a second.
Tangent at 0, sorry, negative tangent at 0 is negative 0.
Hey, he did it for once.
All right.
I don't like
So you end up with 0.
No,
So,
negative
so
0.
if we wanted to find the linearization of this problem, we would say that the natural log of cosine of oh,
Who's on X?
Plus 0.
Why not minus?
well, we
It
always
should be minus
we always
0.
Oh, I guess you.
Exactly what I just freaking said.
Alright, it doesn't matter.
And I was talking about it.
That's not appropriate language.
I said
Okay.
freaking.
So-
Shop.
so there we have it. Oh, sorry, I wrote a lie.
It's not equal to it.
It's not equal to.
Equals.
This would be approximately. Okay, so this is the answer to A. It's the linearization. Now, if we go one more term, we go and add the second derivative. The derivative of negative tangent is going to be negative secant squared. And then the value of negative secant squared at 0 is negative 1, I think.
Sure.
John? Okay, so negative 1 divided by 2 factorial, which is going to be negative 1/2. So the answer to part B is that the natural log of the cosine of x is approximately negative 1/2 x squared.
Money goes.
Alright.
All right. Now, can we look at the graphs of all these things and see if it all pans out?
Yeah.
So let me switch over to the calculator. Let's start with the real function that we're working with, natural log of cosine of x. And the linearization was 0. And the quadratic formula version is negative 1/2 x squared. So let's graph all of them on a standard window, let's say, and see what we get.
What the?
Wow.
Are you in degree or radian or
Well, you are.
No. So what's going on?
There you go.
There's 3 airplanes
Wait.
flying, and
Ass
there's
in
a
the
really
And
big
below.
There's discontinuity. Why is there discontinuity?
Because
What do we know about natural log?
it's only defined for one and above? Or
No.
It's only
for
defined-
x's of one and above?
No?
Or x is a.
I figured
It's,
yeah.
natural log is only defined. What's the graph of natural log look like? Come on.
That's the.
I don't know.
Oh,
It's like the half.
It's that.
That.
Yeah, right.
That.
That's all I need.
natural log is only defined when x is positive. So what's going on with these gaps?
Cosine goes between 1 and negative 1.
This is when cosine is negative. The gaps are when cosine is negative. So you're seeing these gaps in there because natural log isn't defined anywhere. But cosine does periodically go between positive and negative values. So here you have, there's your natural log cosine function. Okay, here is negative 1/2 x squared, and you can see that
Just like
near the center they mimic each other.
Don't forget y equals 0.
And y is equal to 0. Of course, right? Well, why didn't we see the y equals 0 stuff?
Because it's the axis.
Because it all is it's drawing right on the axis.
That's the same.
Okay? And so you could imagine for a very small area right around the origin
It's really chunky.
It's pretty
that it
good.
mimics it, but not very well.
Not very well.
It's approximate.
Are we okay with those ideas? So definition of linearization, definition of the quadratic form. Meaning that it's going to be a Taylor polynomial of order 2. Easy peasy.
Zoom in drawing speed.
Alright.
Yeah, on negative 0.625 to 0.625. It's almost perfect.
Almost perfect.
Can't be
It's close enough for jazz.